Hello, Dan here from howtomechatronics.com, and in this video I will show you how I built an Arduino based 3D wire bending machine. This is actually a typical mechatronics system because it involves mechanical, electrical and computer engineering. I believe many engineering students or anyone who's new into mechatronics would find this video interesting. Personally, I really enjoyed making this project and I'm even more excited about explaining in details how it works and how you can build one yourself. So first, the wire goes through a series of rollers or straighteners. Using a stepper motor, the wire is precisely fed to the bending mechanism, which also uses a stepper motor as well as a small servo for the bending process. There's also another stepper motor called the Z-axis, which actually enables the machine to create the three-dimensional forms. Of course, the brain of the machine is an Arduino board, which along with the other components is attached on a custom designed PCB. As for the program, I made few custom functions for making various shapes like a star, a cube and a simple stand, as well as a manual mode where we can make the wire forms by entering commands through the serial monitor. As usual, I started by designing the project using a 3D modeling software. You can find and download this 3D model from the website article. The link is in the description of this video. For some of the parts like the gears, the bearing pillow blocks and some shaft couplers, I use a 3D printer to make them. The STL files for these parts, which are used for 3D printing, are also provided in the website article. My new 3D printer, Creality CR10, did a great job and printed the parts in a great quality. There is also a link to this 3D printer in the description in case you want to check it out. I continued with preparing the other parts, for which I used MDF and plywood. So once I took all dimensions from the 3D model, using a circular saw I cut the pieces to size. I used 8mm thick MDF and 18mm thick plywood. Once I got them ready, I started with the assembly. First, I made the base out of 2 MDF plates and 4 plywood columns. For securing them, I used a wood glue and some screws. Next, on the top panel, I attached the 3D printed bearing pillow blocks using some 8mm bolts and nuts. We can notice here that I added 3mm thick MDF plates between the top and the pillow blocks so that I get the proper height. Now in these blocks we can fit the 6202 bearings. Their outer diameter is 35mm and the inner diameter is 15mm. So now through these bearings we need to insert a 15mm hollow shaft so that the wire could pass through it. I used a copper tube for that purpose and its length needs to be around 30 cm. In between the two bearings I also inserted a 3D printed gear with a model of 1.5 and 30 teeth. The gear has custom design slots where we can insert M3 nuts and then using M3 bolts we can tighten the gear to the shaft. Next we need to install the Z-axis stepper motor. For that purpose I 3D printed a custom mounting bracket. So I secured the stepper motor to the bracket using M3 bolts and then inserted the 18 teeth gear onto the motor shaft. I used the same method for securing the gear to the shaft as shown earlier. Then, using a 6mm drill, I made 2 holes on the top on which the mounting bracket will be secured. We can notice that the bracket instead of holes has slots which enables the two gears to be properly paired. I moved on with installing the stepper motor for the feeder mechanism. This motor will be directly mounted onto the top plate, so I drilled the appropriate holes on it. Then, using 4 bolts, I secured the stepper to the plate, and in case you wonder what those nuts do here, they actually act as distance nuts because the bolts that I had were longer and couldn't fit into the motor's threads. So now onto the shaft of this stepper motor, we need to insert the feeder. For that purpose, I 3D printed a custom shaft coupler on which I inserted a copper tube which will actually be the contact surface of the feeder. Then on the opposite side of the motor I installed a lever on which I attach a bearing which will press against the feeder. For getting enough grip so that the feeder could move the wire, I will attach a piece of plywood with a T-nut on it and then using a bolt we will be able to control the grip of the feeder. The next step is making the wire straightening system. Using 3 M8 bolts I secured a piece of plywood that I previously drilled according to the 3D model. Now on top of it I inserted the rollers. I made the rollers out of bearings and 3D printed grooved outer rings. 3 rollers go on this side and 2 rollers on the other side. For the other side, I made a slot in the plywood piece so that the bolts stay flush with the piece. Now, using just 2 bolts, we can pair the 2 sides, and using the nuts we can tighten the straighteners appropriately. Once finished with this step, I added 2 more pieces of plywood in front and after the straighteners, which will serve as wire guides. Okay, so now we can move on with making the bending mechanism. First, on a piece of MDF we need to attach the bender motor. Before I did that, the MDF piece that I had needed some shaping, so using a handsaw, a coping saw and a rasp, I easily got the desired shape. Then, using a 38mm hole saw, I made an opening for the bigger stepper that we will use for the bending, a NEMA 23 stepper motor. Also, I drilled some smaller holes needed for attaching the other parts. I secured the NEMA 23 stepper using M4 bolts and nuts, and on its output shaft I attached a gear with a module of 2.5 and 18 teeth. This gear will be paired with a bigger 30 teeth gear, which is a custom designed gear with integrated plate for mounting a MG99 servo. This servo will move a rack and pinion mechanism, which is actually a pin which will pop out of the gear and it will serve for bending the wire. Using a 5 minutes epoxy, I secured a bearing onto the gear and also added a piece of copper tube onto the rack, which will be the contact surface for bending the wire. After the epoxy dried out, I paired the 2 gears by securing the bigger gear in place with a M8 bolt and nuts. Then I inserted the rack and the servo in place and secured it with the screws provided in the servo package. Then I secured the pinion gear onto the round horn of the servo using 2 M3 bolts and nuts. Finally, I attached the horn to the servo, and with this the bending mechanism was completed. What's left to do now is to attach the bender to the Z-axis. I did that using 2 3D printed shaft clamps. First I secured them to the bender plate using M6 bolts and nuts, and then I inserted them into the Z-axis. I inserted the 2 nuts in place, and using the bolts I tightened the clamps to the shaft. So now all moving parts are working properly. Actually, there are 2 more small details to be added, and that's this 3mm nozzle on the shaft where the wire comes out, and at the bottom of the bender I placed a micro limit switch which will be used for setting the initial position of the bender. And that's it, our 3D wire bending machine is almost done. I say almost because now we need to give life to this machine, or connect the electronics components and program it. Here's the circuit diagram of this project. So the 3 stepper motors are controlled using the 3 DRV8825 stepper drivers. For powering the steppers and the whole project we will use 12 volts power supply with at least 3 amps of current rate. For powering the servo we could use the 5 volts coming from the Arduino, but the MG99 servo can be power hungry and the 5 volts voltage regulator of the Arduino might not be able to handle it. Therefore, I decided to use a separate 5 volts voltage regulator, the LM7805, which is good enough to power the servo for this project. There's also a limit switch for the bender, which has a pull-up resistor and it's connected to a digital pin of the Arduino board. Next, in order to get rid of wiring mess and keep the electronics components organized, I designed a custom PCB using the EasyEDA free online circuit design software. The circuit has many connections, so I used both the top and the bottom layer to organize them. I also added pins for selecting the stepper's resolution, added 1 more limit switch connection, and provided additional digital and analog pins coming from the Arduino in case we need them for something. You can find the link to the project files of this PCB design on the website article. So once finished with this step, I generated the Gerber file needed for manufacturing the PCB. Then I ordered the PCB from JLC PCB, which is actually the sponsor of this video. Here we can simply drag and drop the Gerber file, and once uploaded we can review our PCB in the Gerber viewer. If everything is alright, then we can go on, select the properties that we want for our PCB, and then we can order our PCB at a reasonable price. Note that if it's your first order from JLC PCB, you can get up to 10 PCBs for only $2. After several days, the PCBs have arrived. The quality of the PCBs is great and everything is exactly the same as in the design. So now we can move on and install the electronics components onto the PCB. I started by soldering pin headers to the PCB. This enables easier connecting and disconnecting of components when needed. As for the smaller components, like the capacitors, the resistors, the voltage regulator and the terminal blocks, I soldered them directly onto the PCB. Once finished with this step, now we can insert the stepper drivers and the Arduino in place. Then we need to connect the power plug and the power switch to the terminal blocks, connect the cables to the stepper motors on one side and connect them to the PCB on the other side. The servo is connected to digital pin number 2 and powered with the 5 volts coming from the LM7805 voltage regulator. Finally, we can select the stepper resolution by connecting the resolution pins below the drivers. I decided to use 16-step resolution, so we need to connect the right pins instead of the middle ones as seen here on the video. So the electronics components are now ready and we can move on with programming the machine. Here's the Arduino code. For controlling the stepper motors, I will use the Excel stepper library by Mike McCauley. So we need to include this library as well as the servo library for controlling the servo motor. Then we need to define the pins to which the steppers are connected and some variables needed for the program below. In the setup section we need to set the initial position of the servo or the bending pin and also set the initial position of the bender gear. This is done with the help of the limit switch. The stepper motor rotates towards the switch and once it's pressed, the motor starts counting the steps from 0 and position itself to 0 degrees ready for bending. Now in the loop section we wait for commands coming from the serial monitor. If we type manual, we will enter the manual bending mode, or if we type for example star, the star custom function will be executed and the machine will automatically make a star for us. Let's take a look at this custom function. So here we enter a while loop which is executed 5 times, because obviously a star has 5 points. We start by setting the feed value, or that's how much wire will be fed in millimeters. This value is then multiplied by 48, which translates the feed value into appropriate steps for the stepper motor to move. Then using the run function, we rotate the feeder with a speed set by the setSpeed function. We stop when the above feed distance value is reached, and right after that we set the current position value of the stepper to 0. In the next step we bend the wire 52 degrees. This is done in a similar way as explained above. Here we also have an angle constant which is multiplied with the desired angle. Once the value is reached by the motor stops, resets its current position to 0 and then runs the same number of steps in the opposite direction, which actually returns the motor to its initial position. Then again we feed the same length of wire and we set the pin down so that the bender can move to a new initial position which is used for bending in the other direction. The bender pin is then raised and so we bend the wire 105 degrees in the opposite direction. The above commands are repeated 5 times and that's how we get the star form. In similar way as explained above, we make the cube shape or any other shape we can come up with. As for the manual mode, the working principle of the commands are the same, except that we have few more lines for reading the commands coming from the serial monitor. For example, for feeding the wire, we need to type F plus the distance in millimeters. For bending the wire, we need to type B plus the angle in degrees, and for rotating the Z-axis, we need to type Z plus the angle in degrees. So that's how the program that I made works, but of course there are many other ways this to be coded. At the end, I would like to point out that the wire straightening system is actually not working like it should work, because if I tighten it more, the feeder loses grip and the wire doesn't move. For solving this issue, you could try to use different, stronger material than the copper tube or make a different feeder system. So that's it, I hope you enjoyed this video and learned something new. Don't forget to subscribe, and for more tutorials and projects visit howtomechatronics.com.